the place where I try to build cool things and sometimes show you how to make them too. Now today is part 2 of how I made those light panels you just saw. So if you haven't seen part 1, make sure you check it out to see how they were built from cardboard and pillow sheets. In this video, I'm going to be showing you how I programmed everything you just saw, from how the lights change color, to how I controlled it from my phone, or even how it can match the color of my TV. However, this video is actually about something else, because the story of how I programmed this is also a story about knowing your own limits. But you'll see what I mean. So let's get into it. We're going to split this video into 3 parts. How I program the lights, how any device can control them, and how the TV light matching works. As I mentioned in the last video, the lights are controlled off of an Arduino, which means all the code had to be written in C++. I wanted to approach this in a way that made it easy for me to visualize how the code that I was writing would affect the different parts of the lights, since until I finished writing a good chunk of the code, there was really no good way for me to test it. Thankfully, that's exactly what languages like C++ are built for, as they allow me to represent the various objects that make up the light panels in their own groups of code, make a list of all the different things I want those objects to do, and then fill it in later with the code to make it all work. I chose the objects I'm using for this project by thinking about the lights from a zoomed out view and working my way in. That means that we start with having an object for the hexagon, which is then made up of 6 different instances of the triangular panels, where each of them can be made up of the 3 sides, and then those sides are made up of the LEDs within them. The great thing about doing it this way is instead of, for example, writing out code for each of the 6 panels separately, I can write out functionality for what a panel should do in general, and then when I want to run one of those functions for a specific panel, I could use information I'll give to that instance ahead of time about itself, like where it is relative to the hexagon or how many LEDs it has, in order to determine exactly how it should behave. And because they are all defined from the outside in, meaning I start by creating the hexagon, which in turn creates the 6 panels within it, and so forth and so on, all that information that allows that general functionality to work for a specific instance is calculated for me by the code, which is great because that stops me from having to write down, for example, where all 480 LEDs are located. Finding those kinds of optimizations for either writing less code or having the code solve problems for you is like the bread and butter of why I love programming. And when you do it as much as I do, what makes you enjoy it is something that you should never lose sight of. But that's enough chatter about how it works. Let's talk about what it can do. Each object has a set of functions that it can carry out. For the hexagon, its main purpose is to call the same function for some or all of the panels within it at the same time. Its functions include setColor, which changes the color of a selection of panels, ColorShift, which moves the colors of each panel around in a circle, and Rainbow, which activates the rainbow pattern on every panel. The triangular panels have the most functionality. They can fade out and fade back in, fill a panel from any corner up to any %, fill a panel to any corner up to any %, have the colors within the panel rotate around it, and have a rainbow spin around it as well. The sides of each panels and the LEDs within them don't have any specific functions, but their colors can still be set individually. With these relatively few functions, I can combine them in different ways to get almost any light pattern I can think of. Now I say almost because there's still a few things I didn't have time to get done, so while I was writing, I just put an asterisk by them so I could come back to them later, because I still really wanted to get them done. When I decided I wanted to have the lights controllable from either my phone or computer, just depending on which one I was using at the time, I figured I should have them connect to the lights using Bluetooth, because that's a pretty common way to control products like this. The only problem was at this point, I thought that the only way for me to send my data from my phone via Bluetooth would require me to make a custom app, which was just way more effort than I was willing to put in at this point. That's before considering that if I took that route, I have to do something completely different for my computer. And don't even get me started about how if you'd want to do this, you'd have to throw all that work out the window if you wanted to use this code and had an iPhone, because making an app for that is 100% not an option for me. Looking around for a solution, I found a feature that was added into most web browsers only recently, where you can use them to connect to Bluetooth devices and control them from a website. Now, I didn't even know that this was an option, let alone possible. But when I looked into it more, I realized it was the perfect solution, because that means from any device that can access the internet, I can control my lights through it using a website I'd only have to design once. For the programming, I just used plain HTML and JavaScript, and as I mentioned before, if you want to see any of the code for yourself, the link to that is in the description. Also, I didn't use any libraries or frameworks like React to do any of this, because the task at hand was pretty straightforward, and adding that in would have just added more complexities or restrictions that just wouldn't be worth it. For how I designed the website, well, I don't really know. You see, what happened was I was thinking about the way I wanted it to look sometime late at night, and then I fell asleep, and then at 3 a.m. I woke up with the idea and then frantically just drew it on my whiteboard. It was kind of a rough sketch, and I did make some pretty major changes later on, but for the most part, that's just what I went with. Gotta love it when dreams give you actually good ideas instead of the who even knows nonsense. How the website works to do all of those animations is just some run-of-the-mill web development stuff. But the code that runs between you clicking a button and the lights changing is the really interesting part. You see, sending data over Bluetooth is relatively slow, with very little data sendable at once, which means even sending a short text file describing what I'd want to do to be too much for it. So finding the way to make the most out of sending the least data is key. And I think the best way to explain this is through an example. Let's say we wanted to change the color of the entire hexagon to blue. No matter what kind of data is being sent between computers, it's always going to be made up of ones and zeros, so finding the way to send only the required information using the least amount of those is our goal. In this example, that required information would be what object we're trying to change, the hexagon, what function we're trying to run, set color, and the color we want to set it to, blue. What determines the number of bits you'll need to send each piece of information is the number of options that piece of information is choosing from, as you'd want each one to have a unique combination of bits so the receiver can know exactly which one we're talking about. So for sending which object we're trying to edit, well, we know that there are 4 different objects possible, which will only require 2 bits, so that way all of them have a unique combination. From there, we select the combination of bits that represent the hexagon, and then move on to do the exact same process to figure out how many and which bits we need to use to select the set color function. With all that information set, we can then add in the values that the function needs to work by converting the numbers into this representation, as doing so in JavaScript is just a built-in function. And with that, the data is ready to send. Once that information gets to the Arduino, there's code in it to understand what all those bits do and decide which function to run to get the light pattern we wanted. And for comparison, the information that we just sent totaled up to just 63 bits, while if we had sent that small text file I showed earlier, that would have been 920 bits, making this a far better solution. And to be clear, there's nothing unique going on here. Pretty much any wireless device that requires a quick response time, be it a video game controller or keyboard, uses this method. I just wanted to mention it because I find it interesting. One thing you might have noticed back at the beginning was what was happening on the lights wasn't exactly the same as what was happening on the browser controller. The reason is for that to happen, the Arduino would have to send information back to the device controlling it about what's going on the lights, and that was also something I had plans to do. But because of the time, that just had to be another thing I put an asterisk by, since it was really similar to the next thing I had to do in the project, and I wanted to see how sending data from the camera worked first. Speaking about cameras, let's move on to part 2. Now the reason I wanted to add this functionality is because since my lights sit right in front of my TV, I can use them to light up the whole room with the color of what's currently on the screen to make whatever I'm watching feel more immersive. Figuring out how I wanted to do this ended up being one of the more challenging parts of the project because I just had to choose between the best of some really bad options. Sadly, there really is no good way to get the color of anything that could possibly be on a TV screen, and as I spoiled earlier, the best solution I could come up with was to point a camera at the screen so it can figure out what color to send to the lights from there. If you have a better idea, or just any recommendation on this, just please let me know, because I surely need some. Just look how janky the solution is. Like, from the Play-Doh holding it down to the sticks keeping it together, it just ain't it, and I need something better. The camera you see there is known as an ESP32 cam, which is an Arduino with a camera attached to it that comes with wireless connectivity, which you can get for about $7. It works as you might expect. With the camera pointed at the TV screen, it can see the colors that are on it, figure out the average color of what's there, and then send that color back to the lights the same way that data is sent from the browser controller. I didn't think this would be that hard to do, so I coded it up, tested it out, and realized that the average colors I was always getting back was just some muddy shade of gray. I figured it was the camera's fault since it's not all that high quality, so I changed the code to increase the image's saturation and was able to get a slightly better, but still only passable result. But here's the thing, you and my past self was probably thinking that the way you get the average of an image was the same way you get the average of anything else. You just add up all the colors that are there and then divide it by the total. And that sounds right, doesn't it? Well, turns out that I could not be more wrong. Turns out that method does give you the average color, but what we were really looking for was the most dominant color. The difference being the dominant color is the color we perceive the image to be mostly made of. So if I changed my code to do that instead, it would be far more accurate. The only problem is finding the dominant color is far more complex than finding the average color, and doing so would take me quite some time to get it right. I figured what I had was fine for now, and I'll just make that change later, but with no other parts of the project left to do, that meant that later was going to be now. But I also didn't really want to do it now, but I also didn't really have much time left to do it, and at that point it all hit me that there were so many things I had left to do, but all of them were pretty hard, yet didn't add that much value. Some things I didn't mention yet were that I was planning to do all this programming over my holiday break. I came to the realization I just mentioned with only 3 days left within it, and because I was putting in so much effort into this project, I'd basically taken no time of that break off. So I have a long history of just putting 110% into the projects that I work on. And something that I've learned from doing that is most of the time, it is worth it because you end up with something that you're happy with. And whenever you can, I'd still recommend putting in that extra 10%. However, that extra 10% has to come from somewhere. And if the place where you're taking it from is worth more than the place where you're putting it, then there's a problem. I was too focused on getting too many things done that I was taking time away from a far more valuable break and forgot why I was doing this in the first place. So, I took a step back and asked myself 2 simple questions. Why am I doing this? To have fun. Am I still having fun? No, not really. So, I stopped. I might add those changes or plenty of other features I had planned sometime in the future. But for now, I'm going to leave it as is. And if you're planning on taking on parts or even all of this project, still feel free to shoot me a message or leave a comment, because one thing I'll always have time for is answering questions. And until then, I'll see you later.